So thank you for coming to hear a bit about OpenStack at Ocado technology. I don't know how many of you know Ocado. I certainly didn't when I went to my interview, and I thought I was going to talk about bananas, being Ocado the largest online-only retailer. But had I known that Ocado technology behind the scenes is running a lot of technology and is very technology focused. Being the biggest world online-only retailer means that behind the scenes, everything is as any other company as any other technology company, and we have a lot of technology driving all of the work and getting the deliveries out to people. These are just some statistics of the calculations we run, all the complexity that is to run an online grocery retailer, and delivering something that will go bad next day is very different to delivering something that will have a shelf life of a couple of years. So why use OpenStack? We're implementing a DevOps type mentality in Ocado, where developer teams are continuously doing continuous integration and continuous deployment of applications. We're managing a real-time warehouse to deliver your online groceries that has some very nice bots moving about in a grid that need to be controlled. And necessarily those systems are real-time, meaning that being off by a couple of milliseconds can lead to serious issues. That means that it's very important to have a very low latency communication. It means that we have to have everything very close to all of those control systems, need to be very close to the controlled systems. I'm not going to talk a lot more about bots at Ocado. There is a lot of information out there if you are interested in that subject. So how we built everything, and we are just internal consumers of that cloud. We're not selling services on OpenStack to anyone else. We have a basic FI build, which is a full automated install, which just pixie boots the servers and get them started, and does a base template install of the servers. Then Puppet picks them up, orchestrates everything, and get them to and adds them to the correct places with the correct roles, and everything is just that automated. I keep saying to the guys in the team that we want to just boot a server, and half an hour later it finishes all of the processes and it's in the clusters. No one noticed, and it involved no other work, no manual work, no integrations. To attain that objective, we try to keep all of the underlay very simple as possible, and we are only doing Ceph and OpenStack on the underlay, only managing those roles, and then all of the overlay, all of the instances, all of the processes are completely separate. That also allows us to give self-service, and what we really want is all of the developers just to be able to self-serve and do whatever they need to do to get their business working. We just give them all of the tools they need, and all of a sudden they became stakeholders, meaning that they can deploy, do what they need to do, and not depend in any way, shape, or form from infrastructure, or any way, shape, or form from a central bottleneck in infrastructure. Our network is as simple as possible because latency is important. We have BGP to the servers. All of the servers are BGP attached to the network, and everything is routed at that level. We have a backend fabric using MPLS. The idea is to support multi-tenancy at the backend, but we're currently only single tenant. Knowing our environment, knowing how Ocado works and what Ocado requires means that we can get away with some choices and optimize for that target. We have all of the networking done with Calico and IPv4. That means all of the instances are directly attached to the network and means we are single tenant by design. Again, knowing the target, that's not a problem. What we get from that is from instance to instance on different availability zones, we are adding an overhead of something like 20 microseconds by using OpenStack, which is rather negligible. It increases 15–20% from the base network on 10. But when we have to control things real-time bots, that means it's time saved. However, it means we're a single tenant, but being on a local warehouse, that's not a problem. I.e., we're not selling a solution to other customers, and we don't require isolation. How do we do HA? As I said, we do BGP to the servers. That means we are able to implement things like Anycast. I don't know who knows what Anycast is, but we just present the same IP address in 2 places in the network and let the network choose the best route to it. We health check it and remove the route if it's not possible or if it's not working. But that way we get free load balancing. That means, and this is a big problem for most people, that we have no Coro sync, no pacemaker, and no external load balancer required. All of our network does the load balancing and failover automatically for us. If a node goes away, it just removes from the network. We wait for network reconversions, which in BGP is rather quick, and all of the services seamlessly fail over to the current nodes. It also prefers local nodes instead of remote. The closest node will be preferred, even if it's distant. But the route is always present, and we have no need for external load balancers. We have implemented Anycast on things like S3 and Swift interfaces. We have a number of Frados gateway with Ceph, actually. And the network just chooses the closest one. And typically, things are pretty well load balanced. We also run Anycast on all of the services from Horizon, all of the APIs, and a few other services. Like RabbitMQ is also Anycasted. If any of them goes down, the health check detects that the service went down, removes network presentation from that, and everything is seamlessly transferred to the running nodes. However, not all roles support proper multi-master. So what we do is present a single IP address, have that as a floating IP address, which is only available on one node at any given time. So everyone connects to a single node. If that goes away, the system detects it, and we raise the interface somewhere else and recover the service from there. We were having issues with things like MySQL, even though we're using Galera with multi-master clusters, where distributed locking was timing out and killing transactions. Things like Memcache also don't work well with multi-master Anycast. And it requires a real unique master, and then just passes information from one node to the other, and we do that as our HA. Even though it's using Anycast to float the IP address of where the service is, it's not really Anycasted. So Building the infrastructure, we have to give the visibility of availability to the applications. We'll tell the applications, here is an availability zone, and use availability zones for high availability. If something goes wrong, it will tend to only affect one availability zone, and unfortunately sometimes it happens, or we even have Chaos Monkey shutting down an availability zone where things will fail on availability zones. So have the applications replicating data, ensuring that they are HA over the top, and the applications are responsible to maintaining high available and data quality. But we give them all of the visibility of that availability zone. So the applications will know and expect isolation between availability zones. So we have in each availability zone storage and compute. So an instance will live and die with that availability zone. If something goes horribly wrong with one, hopefully it won't affect the others if everything is properly designed. But the instance may become unavailable. And all through these processes, we've been including and bringing the devs on board for them to design based on the architecture for OpenStack. To avoid any collisions between different clusters, again, because we are locality and latency is very important, we have separate clusters for separate locations. We are looking into expanding into regions and then having an overarching look using regions, but currently it's isolated separate clusters. Okay, so as for scheduling, given that we have a real I know cloud providers will overcommit. That's where they make their money. But again, it's knowing very well what we want out of our cloud, how we want to use it, and our environment. In our environment, we never overcommit. We may overcommit very, very slightly in RAM. When I created this presentation, we were allowing overcommit on some levels up to 5% on RAM, and I have since reduced that overcommit level even lower because KSM does help, but on our workloads, the kills are real and will happen every so often. Again, it's knowing the workloads, and some workloads like ours are not real RAM sharers, and KSM won't help, meaning that we will start seeing kills of instances on random. On some levels and some applications, we are enabling hyper-threading, and all of a sudden we are presenting two threads from the same core, so we're overcommitting that at that level and have the scheduler on a one-to-one still. Again, because this is a real-time warehouse, we don't overcommit or tend to avoid overcommitting. We do a one-to-one mapping, i.e. if someone requests for a one core, they will get one core reserved for them. Enabling hyper-threading, that means one core equals one thread, but it's certain workloads only. On much larger instances, we tend to do NUMA awareness. We've been working on passing all of the NUMA up stack to make all of the applications and all of the instances running on top completely NUMA aware, so they are aware of the environment they are running on. We are doing physical reservations. When people ask for one core, they get one core. And we have different aggregates to isolate and separate workloads. There are workloads that are non-shareable that we will never enable hyper-threading because we need to be sure that when they request CPU time, they will get that CPU time. And there are some where we enable hyper-threading, and with the same scheduling rules, they still have not so not so committed, so many committed resources, but still they get the physical resources in. And sometimes we are even undercommitting. There are certain workloads, for example, all of the control systems for the bots, that we undercommit, where we say and present less resources than we have physical available, just to then be able to do I/O, network, all of that. That still uses resources, and they not interfering with any of the resources. So I don't know if you have any questions.
So Ocado presented the Amazon Summit. What do you think about Amazon's public cloud coexistence with OpenStack?
So the question was, we have presented on the Amazon Summit. What do I think about the coexistence? I'm probably not the right person to answer that. I do the internal cloud, but my opinion is horses for courses. There is space for everyone. Amazon presents an interesting scale for you to work in that it's very hard to do on site. But again, I'm not the correct person to give you that answer. Any other questions?
One question. You said you do CPU allocation, one physical to one virtual CPU. From some part of official OpenStack documentation, I read that you may overcommit CPUs up to a ratio of 1 to 16, which sounds a lot to me. Now, given your mapping, there's a pretty severe difference. How do you explain it?
So the question was, by default, just rephrasing, by default OpenStack says use an overcommit on CPUs of 1 to 16. Why am I using 1 to 1 when I could do that? Again, it's knowing workloads. On certain circumstances, it may be wasteful. The issue is we're managing a real-time warehouse. So whenever those control systems want CPU, I need to ensure that they get that CPU time and everything is running. There are online a few videos of those bots moving around, and trust me when I said I've seen them live, they move really fast. So if the control systems don't have enough CPU time, things can go awry, let's just say like this. And it's really important on those systems to ensure everything is there and reserved. Again, it's knowing the workload you're running at, it's knowing what the application is, it's knowing what the requirement is. I don't know, but I'm going to bet there are some cloud providers that run at 16 to 1 or run at 32 to 1 or even larger than that. But then again, it's knowing the performance at the end of the day, is making sure that whenever you need that performance, when you need that CPU time, you get that CPU time. Because on some workloads, you just can't risk not having that CPU available when you really need it.
Can you tell us anything about the size of the cluster, the machine?
We have several clusters. The largest one, and don't quote me on this because I'm saying things from the top of my head, the largest one has just over 2,000 CPU cores and 15, 16 tera RAM. Usage-wise, that CPU cluster is still on ramping because we just installed it, so it's pretty much idle nowadays, but it will be used in the next couple of months. On our typical clusters, we tend to run on 80, 90% full, and we have expanded when we need it. But again, it's economy and managing too many free resources with too much cost, and just managing both, but enough free resources when we need to maintain something.
Are you still, excuse me, are you still running analytics on the Google Cloud? For the data generating
I'm not, sorry, the question was, are we still running analytics? I'm not the correct person to tell you that, sorry. If you give me your contacts, I can, there are other people, and Ocado is a big organization. I don't know exactly the things we are running on Google, sorry. No questions? Okay. Sorry.
How large is your team that supports the OpenStack?
My team is 8 people big. We do more things than just OpenStack, but we're mostly focused on internal storage, compute, and things like OpenStack. So on that, we're hiring because we need more people to do OpenStack. Sorry, shameless plug. Well, thank you for your time, and thank you for being interested in Ocado.